So for the last, couple of decades, we've basically all been living in the era of the cloud. But what happens next? Well, today we're going to dive into a pretty bold vision for a post-cloud world, one that's built not on just trusting big companies, but on actual mathematical proof. We're talking about a whole new kind of digital infrastructure, one that's verifiable and has incredibly high assurance.
All right, so here's the game plan. First, we're going to talk about a fundamental problem with the cloud as we know it. Then we'll introduce a totally new model based on a simple idea: verify, don't trust. After that, we'll look at the tech that makes it all possible, walk through the 10-year plan to build it, and finally, kind of dream a little about what this future could actually look like.
Okay, so to really get where we're going, we first have to understand the problem we're trying to solve. And it's this critical, often kind of ignored vulnerability that's baked right into the DNA of the cloud today.
It really all comes down to this one simple question. When you upload a file to one of the big cloud providers, you're trusting them, right? You trust they won't peek at it, or misuse it, or let it get stolen. But here's the kicker. Can you actually prove any of that? The honest answer right now? Nope, not a chance.
This image right here, this gets to the absolute heart of the issue. It's something called root access. See, in the current model, the cloud provider always has the master key. They have total access to the servers that hold your data. And that forces every single one of us into a position of what's called implicit trust. You basically just have to blindly hope they'll do the right thing.
So let's be super clear here. The cloud itself is an amazing innovation. That's not the bad guy. The real problem is that its security, at the end of the day, is based on a human promise, a corporate policy, not on some kind of verifiable technical proof.
Okay, so we've seen the problem. Now for the really cool part: how we can build a completely new model. This is about shifting the entire paradigm away from just trusting promises to actually verifying with logic.
So instead of just taking the provider's word for it, this new approach lets you use math to verify that their infrastructure is secure before you ever let your data touch it. You don't have to trust anyone, you get to prove it for yourself.
And this is all possible because of a process called Bring Your Own Verifier. It's actually a pretty straightforward three-step dance. First, you, the user, define your own rules and security needs. Second, the system gives you back a cryptographic proof showing that it meets all your rules. And only then, once your own logic gives the green light, does your app or your data get deployed. You know, this just flips the whole script on the relationship we have with these companies. The provider is no longer the guardian of your secrets. They basically become a utility, just like your power company. They provide the electricity, but they have absolutely no technical way to see what you're doing with it.
Now I know what you're thinking. This all sounds fantastic, right? But how is it actually possible? Well, the whole system is built on two foundational pillars of technology that work together to make it a reality.
And what's really cool is how cleanly it separates into these two components that make high-assurance computing work. You've got a software philosophy on one hand and a hardware capability on the other.
Okay, so the software pillar is called Zero Trust Architecture, and it has a really simple rule. Never trust, always verify. No user, no machine, no bit of code gets a free pass. Every single request to access anything has to be checked and approved, every single time, no exceptions.
Then you've got the hardware pillar, which uses something called isolated enclaves. The best way to think about these is like a digital Fort Knox built right onto the computer chip. All the work happens inside this cryptographically sealed box, and your data is completely inaccessible to everything else, even the operating system, even the provider's own engineers.
And when you put it all together in a table like this, the difference is just, well, it's night and day. On legacy clouds, the provider has root access, the keys to the kingdom. In this new model, they have zero access. Legacy clouds rely on you implicitly trusting them. This model uses Bring Your Own Verifier. It's a total shift from centralized risk to a distributed system with no single point of failure. And listen, this isn't just some theory sketched out on a napkin. There is a detailed, decade-long plan to actually build this new foundation for the internet, piece by piece. The whole roadmap is laid out in 3 big phases over the next 10 years. It starts with building that core foundation of security and identity, then it moves to scaling up for massive workloads like AI, and it ends with the creation of a truly mission-critical global fabric.
So, Phase 1, which covers the first 2 years, is all about getting those security layers absolutely right. This means launching with those hardware-isolated enclaves and a decentralized identity system that gets rid of the big, centralized honeypots of personal data that hackers just love to target.
Next up, in Phase 2, it's all about scale. This is where the network gets powerful enough to handle the massive data needs of things like AI training and high-speed financial transactions. It also brings in something called smart compliance, where things like GDPR rules are enforced automatically with crypto proofs instead of manual audits. Pretty cool, right? And then we get to the grand finale, Phase 3. This is the really ambitious part. The goal here is to become a true global fabric for the world's most critical infrastructure, achieving a state where there is literally no single point of failure. The network could keep running even if huge chunks of the internet went down.
So, okay, that's a ton of tech and a huge plan. But what's the point? Why does building all of this actually matter? Let's take a quick look at the kind of real-world impact this verifiable, high-assurance system could actually have on our lives.
I mean, by the time this roadmap is complete, the vision is for this network to be the absolute backbone for society's most important and sensitive data systems. We're talking about things like secure digital models of a nation's infrastructure, completely sovereign healthcare databases, and even neutral settlement layers for global finance.
And this slide really brings it home. Just take a second and imagine a world where the absolute privacy of your most personal medical records, maybe even your genetic data, isn't just promised by a company's privacy policy, which, can change, but is actually mathematically guaranteed by the infrastructure itself. That's a real game changer.
At the end of the day, what we're really looking at here is an evolution. We are moving away from the vulnerabilities of the old black box cloud, where we just have to cross our fingers and trust what's going on inside. The future really does belong to systems that we don't have to trust simply because we can prove that they're secure.
And so that kind of leaves us with one final big question to think about. For decades now, we've built an entire digital world based on trusting other people and other companies. The question is, are we finally ready to build the next version of the internet on a foundation of verifiable proof?